Okay, this is our atomic structure part 2 for November 6th of 2012. And we just went over all of our subatomic particles and the basics of atomic structure. Now we're going to take a look at the ways in which we document this. And there's a ton of numbers that show up on the periodic table or show up every time you see an element. And sometimes you'll see an element name or element symbol, and it's surrounded by all of these numbers. So we're going to take a look at what these numbers are and what they mean, and how you can use these numbers to tell you a little bit about what you're looking at. The first is the atomic number. This is the major number that you can derive by looking at the periodic table. The periodic table is actually arranged by increasing atomic number, starting with helium at the top left and going all the way down to the newest element, which was element number 113, which is as yet unnamed because it was only developed in a laboratory this year. So the number of protons in the nucleus of the atom is what determines its atomic number. Every element has its own atomic number, so every different element has a different number of protons. This is what makes elements different from one another. The periodic table is arranged in order of increasing atomic number, so the further you get towards the bottom, the larger your atomic numbers become. This number determines the identity of the element. So if I tell you the atomic number of 1, you automatically know that I'm talking about a hydrogen atom. Whereas if I say an atomic number of 6, you automatically know that I'm talking about a carbon atom, or any other. Pick any number of elements on the periodic table, and you can identify them simply by that number. So keep that in mind. That is the atomic number, and it is the number of protons in a nucleus. Now, next to each symbol, you will also find a mass number, and the mass number is the number of protons plus the number of neutrons in the nucleus of an atom. Now, this is referred to as the mass number. This is not found on the periodic table. The reason for this is that it refers to a single atom of an element. And so the periodic table only deals with that element in general, with all of the atoms. So a carbon atom, for example, would have 6 protons, and every carbon atom has 6 protons. Where the mass number can actually change, where you have carbon 12, you have carbon 14, so you have different atomic mass, or you have different mass numbers for carbon. So keep in mind that this mass number is not on the periodic table. Please make sure you note that, because a lot of people think that the atomic mass is the same as the mass number, and I don't want you to get these two confused. So the mass number is the number of protons plus the number of neutrons in the nucleus of an atom. And because it is a number, note that it is a number, not a mass or an average. Because it is a number, it will always be an integer. So you can tell that the atomic mass on the periodic table is not the same as this number, because those numbers have decimal points. This number will not ever have a decimal point. So the shorthand is written like this, where you have your symbol for the element. This, for example, here is carbon, and you have the mass number of 12, and you have the atomic number of 6. So the mass number is written as a superscript on the left-hand side of your element, and the atomic number is written as a superscript and is also on, or written as a subscript rather, and is also on the left. And so you have the larger mass number, because this is protons plus neutrons, and then you have the atomic number, which is simply the number of protons in the atom. So what we're looking at here is we're looking at an atom of carbon that has 6 protons and 6 neutrons to make the mass number a total of 12. There's an alternative way to write this, and this would be carbon 12. And that means that the 12 is the mass number. That is how many neutrons plus how many protons there are. Now, we will always know how many neutrons there are because the number of protons is not going to change. Because if we change the number of protons in a carbon atom, we're turning it into something else. We're turning that carbon into a nitrogen or an oxygen, and the carbon will always have a proton or an atomic number of 6, because that's the identifier for a carbon atom. Okay? We talked briefly about isotopes last week, but I want to revisit this now that we've talked about the atomic numbers and the mass numbers. The isotopes are atoms of the same element, but they have a different number of neutrons, and so the mass numbers will be different. The example that I have here is that all lithium atoms have 3 protons, but some lithium atoms will have 3 neutrons, some will have 4, and some will even have 5. And you'll notice here that we abbreviate these. The lithium is always there because it's still lithium. The reason we know that it's lithium is lithium has 3 protons. And so you see this 3 protons, 3 protons, and 3 protons. And that's all the same. However, the mass numbers are changing, and that simply means that this only has 3 neutrons, while this molecule has 4 neutrons, giving it a mass number of 7, and this has 5 neutrons, giving it a mass number of 18, or of 8, sorry. And so this is what an isotope is. So isotopes, this is a definition that you need to have down in your notes. You need to make sure that you understand that they are the same element, but they have different numbers of neutrons. They don't have different numbers of protons. They have the exact same number of protons, and you'll notice down here they have the exact same number of electrons. So isotopes, same atomic number, different atomic mass. Okay? Despite the differences, isotopes of an element are chemically alike because they have identical numbers of protons and electrons. So you can have different isotopes of an element, but it's still, for example, the isotopes of lithium, they are all lithium because the protons and the electrons are the things with charge, and they're responsible for the way that chemical behaves. So we say that electrons are the most important in determining how that chemical is going to react, and the electrons aren't changed and the protons aren't changed. And so isotopes are simply different masses of the same chemical element. Carbon-12 is the standard used for calculating the atomic mass unit. It is one of the most famous isotopes because it is one of the ones that we have photographed, and it is one of the ones that we know the weight of. All right, so the atomic mass unit is actually 1/12 of the mass of a carbon-12 atom. And the atomic mass is something we're going to come back to. This is a weighted average, and this is what we calculated in our Candium lab with our M&Ms and Skittles and York pieces and lemon drops, where you actually calculated there are this percent of this isotope and they weigh this much, and you put those all together in a sum, and that is the weighted average mass of atoms in a naturally occurring sample of the element. So when we look at a sample of carbon, for example, we will find some carbon-12 and we will find some carbon-14, and that occurs naturally. So we take a look at how much of the carbon atoms are a carbon-12 and how much of the carbon atoms are carbon-14, and we calculate that, and that is the atomic mass. That is the number that you do find on the periodic table. We're going to talk more about the periodic table on Thursday, and I'm going to make a video on that here in just a moment, but that will be played for you guys when I leave for my training on Thursday. Now, the sub should pass out a worksheet that I have made for you, and I'm going to show you that worksheet, and I'm going to show you how I expect for you to do it. This is the atomic structure worksheet that you'll be getting. You'll notice here that I've actually put all of this information on the worksheet itself, told you the mass number, the atomic number, and the elemental symbol. Now, the one thing we haven't spent much time talking about, but I plan to do this with you guys this week, is the ionic charge. What makes an ion? And we've talked about how you have a positive charge because you've taken electrons away. So just keep in mind that as you take electrons away, your atom will become an ion. It will become charged, and that's how you keep track of the electrons involved in your chemical. So I'm going to show you here as an example what I expect for you to do here. I've given you an element, and that element has a mass number of 1. If you look down here at hydrogen, this it has a mass number of 1, and it has an atomic number of 1. So we know that the atomic number, which is this number down here, is 1, and the mass number is also 1. This means the atomic number, of course, is the number of protons that we have, and the mass number is the number of protons plus the number of neutrons. So if I have a mass number of 1 and an atomic number of 1, that means I have 1 proton. So this is the number of protons, for example. Okay, so this is the number that's going to come over here. So, and the mass number is protons and neutrons, plus neutrons. Okay, then 1 plus what is 1? That will give me my number of neutrons, which has to be 0. And because this hydrogen does not have a charge, it doesn't have an ionic charge here, my number of electrons is going to be equal to my number of protons. Okay? Now I'm going to show you one that has an ion. This is an ion of hydrogen. You'll notice it looks pretty much the same. It's got the same chemical symbol. It's got the atomic number of 1 still, but it now has a mass number of 2, and it has a charge of plus 1. So my atomic number, of course, stays the same, but my mass number is now 2, and that means that I have 1 proton. That's the atomic number again, and now my mass number is 1 more than that, and so it means I have a neutron. Now the problem with this is my hydrogen now has a positive 1 charge, which means that my protons plus electrons has to lead to a positive 1 charge. The only way that can happen is if there's not a negative charge to balance out, which is going to mean that I put 0 electrons here. Okay, and again, that's coming from the fact that this hydrogen has a positive 1 ionic charge. Okay, so that positive 1 ionic charge means no electrons, because there is only 1 proton, and that proton has a positive charge. And the electron, of course, has a negative charge. Positive 1 plus 0 means positive 1, which is what we have on our ionic charge number over here. Okay? If you have any questions, please help each other out here, because some of you guys are going to get this right away, and some of you are going to struggle, particularly with the ionic charges. The atomic number and the mass number, if you can look at this and read it and read the key up here, you should have no problems with that at all. But please do help each other out, but don't just copy off of each other's paper, because I will be giving a quiz over this material when I get back tomorrow. So you will all need to know how to do this. So if you help each other, do it by actually showing one another how to work these problems, rather than simply giving someone else the answers, because that really doesn't help them at all. So do the rest of this worksheet as practice, and have it completed for tomorrow, along with any questions. You can put stars beside any ones that you're really struggling with, and I will go over them with you tomorrow when I get back. Okay? Have a fantastic day, and I will see you tomorrow.